All right, you guys, let's start talking about right triangle trigonometry. So my guess is that a lot of you have already had right triangle trigonometry. You've been taught this before. It's usually covered in like high school geometry. And so in this class we started with unit circle trigonometry, which gives you the full definition of sine and cosine. So this unit, it was probably review for a lot of you, but let's make the transition from the unit circle to the right triangle trigonometry that you probably already do. If you didn't know that, it's okay. But so if we take a look at the unit circle, and you can see this inner blue circle here that I have drawn is the unit circle. You can see it has a radius of 1. And we know that any point on this unit circle, the x value is the cosine and the y value is the sine. So if we start with that unit circle, and you can see that the right triangle that is formed when you drop a perpendicular down to the x-axis. Okay, so the distance above the x-axis is, which is the y value, is the sine, and the distance over on the x-axis is the cosine. So that's the x value. Okay, let's scale that up. Let's take that unit circle. If we scale it up to a circle that has a radius of r, okay, you can see we can also scale up that triangle. All right, so now instead of the hypotenuse being 1, the radius of the unit circle, the hypotenuse is now the radius of the larger circle with a radius of r. Okay, and then it's just a similar triangle, right? We have the same angle with two angles the same, right? So it's a similar triangle by AA, right? If you remember your geometry theorems, we have two angles the same. So these two triangles are similar. And so if we scale up the hypotenuse by a factor of r, we can also scale up the legs by a factor of r, right? So if we call r as the hypotenuse, r times sine theta is what we're going to call the opposite side, because it's opposite the angle that we're interested in. The angle that we know or that we're interested in is the side opposite that is r sine theta. And the adjacent side, which means it's adjacent because it's adjacent to the angle that we're interested in, okay, and that's r cosine theta. All right, so now we can take those definitions and we can see that if we take the opposite side, which is r sine theta, and divide it by the hypotenuse, which is r, we get sine theta. So sine theta is opposite over hypotenuse. We can do the same thing with the adjacent side. The adjacent side is r cosine theta. If we divide it by hypotenuse, we get cosine. So, and then, let's go down here to tangent. We know that tangent is sine over cosine. So if I take the opposite side divided by the adjacent side, the r's will cancel and we get sine over cosine. So tangent is opposite over adjacent. And oftentimes people use this little mnemonic down here to remember the definitions of sine, cosine, and tangent. Sohcahtoa, right? So it's the letters stand for, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so Sohcahtoa is, if you want to remember that's often used to help you remember the ratios of the sides. Okay, so let's use those definitions. All right, so let's start out with this first example. We have a triangle. We have a 15-degree angle. Get my pen to work. We have a 15-degree angle up there. And I think I'm going to change to blue. Or maybe green. I don't know. Try green today. All right, so, and then we're given the hypotenuse. Now I didn't draw little right triangle symbols, or right angle symbols here, but we're going to assume that that angle there is a right angle. Too many cords on my desk here. Okay, so, and we're given the hypotenuse, and we want to find this side length here. And that side that we're interested in finding is the opposite side. Okay, so we want to find the opposite. I'm just going to abbreviate op. And we're given the hypotenuse. Hype. Okay. So, if we look back up at our definitions of sine, cosine, and tangent, let me go back up here. We want to find the trig function that involves opposite and hypotenuse. Okay, so the one that involves opposite and hypotenuse here is the sine. So we can say, what we can do is we can say that, write this up, that the sine of 15 degrees is equal to, and I'll just call this opposite side x. Okay, it's equal to x over the hypotenuse, which is 28. Okay. Now we can put sine 15 degrees in our calculator and calculate a number. So now we just need to solve for x. All right, so x is going to be, if I multiply both sides by 28, it's going to be 28 sine of 15 degrees. And I can plug all that into my calculator. And when I do that, I get that x is 7.25. And because we have units on this triangle, this hypotenuse is 28 feet, then we should put units on the side we just solved for, which is going to be feet. I'll just abbreviate FT. Okay? All right, so this is just another example. Again, so we have an angle, 18 degrees. We're given the opposite side this time, and we want to calculate the hypotenuse. Okay, so again, we've got, we know an angle, okay, and we've got the opposite, and we want to find the hypotenuse. So we want to find the trig function that involves opposite and hypotenuse, which is sine. Okay, so I could just say that sine of 18 degrees is equal to opposite, 50, over the hypotenuse, which I'm going to just call x. Okay. And once we've got that, then we just need to solve for x. So I'm just going to kind of cross multiply here. And then, you know, if I take both sides times x, I get x sine 18 degrees equals 50, which means that x is equal to 50 over sine of 18 degrees. Okay, that's all stuff I can plug into my calculator, and when I do that, I get 161.8, and the units in this problem are meters. Okay, so notice I'm using degrees in both of these problems, so you want to make sure that your calculator is set to degree mode when you're solving these problems. These particular problems, but you'll have to be careful, you know, to set your calculator to the correct mode depending on what units the angles are given in. All right, so let's take a look at the next example. All right, so here we have an airplane. It says an airplane's altimeter reads 8,000 feet. If the angle of the flight with the ground is 5 degrees, how many miles will the plane need to travel through the air before it reaches the ground? Okay, so we have a plane at 8,000 feet, okay, and it's coming in for a landing. All right, so I'm just going to draw one side here, 8,000 feet. Okay, so that represents the height. Here's the little airplane right up here. I'm not going to be fancy and draw any airplane. That's just where the airplane is. Okay, here's the airplane. All right, and it's coming in, and its angle is 5 degrees. Okay, so we're coming in kind of a really shallow angle, right? The angle it's coming in to, with respect to the ground, is 5 degrees. All right, and then we're asked to find how many miles the plane will need to travel through the air before it reaches the ground. So we're looking for the air distance, not the distance on the ground, but the air distance. So I'm going to call that x. Okay? So again, we have an angle, we have a couple of sides, so we can use trigonometry to figure this out. We're given, again, the opposite side, and we want to find the hypotenuse. Okay. So again, opposite hypotenuse, that should tell you to use sine. So I'm going to write the sine of 5 degrees is equal to opposite over hypotenuse. So 8,000 over x. Okay. So then I need to solve for x. So x is going to be equal, similar to the problem we just did. We're going to get 8,000 over the sine of 5 degrees. And I put that in my calculator, I get 91,789.7 feet. Okay. So, that gives us the number of feet, but they're asking for the number of miles, right? How many miles does it have to travel through the air? Okay. And we're given that they're 5,280 feet per mile. Okay, so we just have to convert feet to miles. So I'm going to take the 91,789.7 feet, and I'm going to use a conversion factor. I have 1 mile per 5,280 feet. Okay. You can see now the feet will cancel and I'll get miles. So that gives me, kind of running into my numbers here, but 17.38 miles is what I get when I convert those feet to miles. All right, so here's another problem. Done. All right, here's another series of problems we can work on. Now, in this one, we just have a couple of triangles, the same as we did before. We're given an angle and a side, and we just got to figure out what trig function to use. So in this one, we have a 15-degree angle. We know the hypotenuse, and we want to find the adjacent side. So we're looking for a relationship between the adjacent and the hypotenuse, right? So that should tell us cosine. So the cosine of 15 degrees is equal to adjacent, which I'm just going to call x, over the hypotenuse. And I can solve for x. I'll get x is equal to 10 times the cosine of 15 degrees. If I plug that into my calculator, I get 9.66 kilometers. All right. All right, this one's similar, only instead of being given the hypotenuse, we're given the adjacent side. All right, this is the hypotenuse, and this is the adjacent side. So we can say the cosine of 15 degrees is equal to 80 over the hypotenuse, which we'll call x. So in this case, we're going to get x is equal to 80 over the cosine of 15 degrees. And when we put that in our calculator, you'll get 82.82 feet. All right. All right, then we have a word problem here. Okay, we have a small town fire department. Needs to order a ladder. that will reach the top of the tallest building in its community, a 50-foot hotel. For safety reasons, the angle to the ground must be 65 degrees. What is the shortest ladder that the fire department can order and still reach the top of the hotel? All right, so let's draw this. Let's say this is our hotel, standing up straight and tall. It's 50 feet. Okay, we want to be able to reach the top of it with a ladder. So there's our ladder. The ladder has to make an angle at 65 degrees. And we want to know how tall the ladder has to be. How long is the ladder? And the ladder is the hypotenuse in this case. Okay. So, again, we have an angle. We're given the opposite side, and we want to find the hypotenuse. Okay. So, what do we need to use to figure this out? You need to use the trig function that involves opposite and hypotenuse, which is sine. So the sine of 65 degrees is equal to 50 over x, opposite over hypotenuse. So x is equal to 50 over sine of 65 degrees. And that means that if you plug this into your calculator, you get 55.17, which is, because it says to round to the nearest foot, we're going to round that to 55 feet. Okay? All right. Now we have more. All right, so we have more triangles. All right. You can pause the video at any time if you want to just go ahead and do these, and then you can use the video to check yourself. But, okay, so here's another one. We just have some triangles. We're given the angle of 20 degrees. We're given the adjacent side, right? And we want to find the hypotenuse, right? All right, so adjacent, hypotenuse. That's not the hypotenuse. That is the opposite side. All right, that's the opposite. Okay, so, all right, what trig function involves the opposite and the adjacent? It's the tangent. So we're going to choose the tangent. Tangent of 20 degrees is equal to x over 9 feet. All right, so we can solve for x. X is equal to 9 tangent of 20 degrees. And if we plug that into our calculator, we get 3.28 feet. All right, so got another one. You're given an angle of 10 degrees. The opposite side is equal to 54 centimeters, and we want to find the adjacent side. Okay, the trig function that involves opposite and adjacent is tangent again. So the tangent of 10 degrees is equal to 54 over x, our unknown side. All right, so again, let's solve for x. X is equal to 54 over the tangent of 10 degrees. All right, put that into your calculator. 306.25 centimeters. All right, let's see what else we got here. We got another word problem. What's going on here? All right. Trying to get my mouse to work. Okay, so in this word problem here, we have a carpenter that wants to build a ramp to make a school accessible to the handicapped. The door is 6 feet above the ground and the ramp must be at a 6-degree angle to allow easy use. How far above the doorway should the carpenter start the ramp? Alright, so let's just draw what this looks like. Make a little triangle. Let's say that doesn't look like 6 degrees, but you know. So it's a really shallow angle, 6 degrees, right? So we'll just assume that's 6 degrees. Alright, that's the ground. The door is 6 feet up. Okay, and what we're asked to figure out is how far the ramp needs to start from the doorway. Okay, so we want to find this horizontal distance. Alright, well, so this is the opposite side. This is the adjacent side. And if we want the relationship that involves opposite and adjacent. So we want tangent. So the tangent of 6 degrees is equal to 6 over x. Okay? And to solve for x, we're just going to divide both sides by tangent, multiply both sides by x, and we get 6 over tangent of 6 degrees. And that's going to give us 57.1 feet. Alright. So, got a few more problems to do. Example 7 now. We have a 3, 4, 5 triangle. And now we're trying to find the angles that correspond to a 3, 4, 5 triangle. Alright, so the other ones we were trying to find sides, now we're going to find angles. But, you know, we can use sine, cosine, and tangent to do this. So I can write the relationship that the sine of theta is equal to, again, it's opposite over hypotenuse, so the opposite is going to be 3, and the hypotenuse is 5. Okay. Now we're going to have to use our inverse trig functions to figure this out. So theta is equal to the inverse sine of 3/5. Okay. So if you calculate the inverse sine in degrees, if you use degree mode on your calculator, you'll get 36.87 degrees. Okay. Now all of these angles are you know, going to be positive in the first quadrant. So it's not like we're going to get multiple angles. We only are interested in one angle because it's a triangle. All right. So that gives us theta. What else could we do? We want to find phi as well. Now we could also use the sine for phi. So the sine of phi would be 4 over 5. We could also say that the cosine of phi is equal to 3 over 5. Or we could say that the tangent of phi is 4 over 3. We could use any of those to figure it out. Or we can also use the fact that the angles in a triangle all add up to 180 degrees. And we already know one of them is 90, right? We know theta is 36.87, so really, to find phi, probably the easiest thing to do would just be to take 90, right? Because we know the two acute angles have to add up to 90, and subtract the angle that we know. It's 36.87. Okay. And then we get 53.13 degrees. Okay, that's probably the easiest. But you could use sine, cosine, and tangent if you wanted to. And you should get the same thing. Alright, so we have several problems down here. And this, in addition to being application of sine, cosine, and tangent, also introduces the standard notation for labeling right triangles. Or labeling triangles in general. Usually what you, and if you've ever done the law of sines or law of cosines, that's not covered in this class, but the law of sines and the law of cosines uses this same labeling. where side A is across from angle A, side B is across from angle B, and side C is across from angle C. But in this case, we're going to call angle C the right angle. Okay, so they don't have any, we don't have any triangles drawn, so we're going to have to draw our own here. So let's take a look at the first example. We're just given two things. We're given actually two sides. So let's draw a triangle. We want a right triangle. All right, so I'm just going to draw a right triangle here. Yeah. I don't like the way it's pressure sensitive and it makes it thick. All right, so there's a right triangle. And we'll call this angle A, we'll call this angle B, and the right angle is angle C. So this side is C. The side opposite of B is side lowercase b. The side opposite of angle A is lowercase a. Okay. And we're given that A is equal to 14. Lowercase a, the side, is 14. And we're given that B, side B, is 43. Okay. And so now we want to find the rest of the angles and the rest of the sides. All right. Well, we've got a number of things at our disposal to figure this out. One thing that we've got is the Pythagorean Theorem. So I know that c squared is equal to a squared plus b squared. So 14 squared plus 43 squared. And I can solve for c then. So if I take the square root of both sides, right, then c is the square root of this. And I get that c is equal to 45.22. Don't have any units, so we'll just leave it at that. All right. We need to find an angle, so I don't know. We could take angle A. We were given the opposite and the opposite and the adjacent sides, so we might as well do the tangent of A is equal to 14. The opposite side over 43. And so now we can just solve for A. The tangent inverse of 14 over 43 is going to be A, which is 18.03 degrees. Okay. Now, the only thing we have left to find is angle B. And I'm just going to use the fact that all of the angles in the triangle have to add up to 180. We already know that one of them is 90. So if I take the remaining 90 and subtract the 18.03 degree angle that I just figured out, I get that angle B has to be 71.97. Okay. All right, so there are three more here. They're very similar. I would say you could probably pause the video at this point and come back to check your answers. I'll go ahead and work through them all, and if you don't need to see the full solution, you can just skip through this and just to check your answers. All right, so again, I'm going to draw a triangle here. We're given side C and angle B. All right, so if I just draw a right triangle. All right, there's a right triangle. We know side C is 54. That's our hypotenuse. Okay, this is angle A, this is angle B. And side B is opposite of angle B, so we're going to call this B. And we're going to call this A because it's opposite of the angle A. And it says angle B is 75 degrees. 75 degrees. All right, so cosine, let's see. Let's start out by, let's start with this, trying to find this side, A. Okay, so if we want side A, right, that's the adjacent side. And we've given the hypotenuse, so I could say that the cosine of 75 degrees is equal to adjacent A over the hypotenuse 54. Okay, so that tells us that A is equal to 54 cosine of 75 degrees, and that gives me 13.98. All right. Now, if I want side B, I could use sine because that's the opposite side, right? So the sine of 75 degrees is equal to B over 54. Okay, so if we solve for B, we get B is equal to 54 sine of 75 degrees. Okay, and that gives us 52.16. All right, last thing we need to find is angle A. Angle A, we already know angle B, and we know the 90-degree angle. So again, the easiest thing to do would just be to subtract the 75 degrees from 90. Oops, 75 degrees, and we get 15 degrees. All right, that takes care of part B. If we look at part C, so all these problems are pretty much the same. They're just given different quantities, right? Sometimes we're given sides, sometimes we're given angles, sometimes they're different sides, different angles. That's all there is to it. All right, so I'm just going to draw another triangle again. Right triangle, right angle here. Better indicate it because it doesn't look that great. Let's call that angle A, this angle B. This is side C, this is side A, and we're given B is equal to 32, and angle B is 27 degrees. Right here. All right. Well, let's see. We could start by finding the hypotenuse, let's say. There's not one way to approach this problem. If I wanted to find the adjacent side first, I could use tangent and do 32 over A is tangent 27. But I'm going to take the sine of 27, and I'm going to find C first, okay? So 32 over C. Okay, so that gives us C is equal to 32 over sine 27. And that gives us 70.49. Okay, so that's side C. If we want A, like I was just saying, we could take the tangent of 27 degrees, and we know that that's equal to opposite over adjacent, so 32 over A. So A is equal to 32 over the tangent of 27, and we get 62.80 for side A. And then angle A, again, we're given angle B, so we might as well just subtract angle B from 90 to get angle A. Okay, so that gives us a 63-degree angle. All right, last one here. Let's draw another triangle. And in this one, we're given side A. Let me label the angles, and then I'll know what side A is. Okay, so we're given side A is equal to 9. We're given side C, which is the side opposite the right angle, is equal to 23. All right, so where do we want to start? Well, let's start out by finding angle A. So it doesn't really matter. There's a number of different ways we could approach this, but I know that the sine of A is 9 over 23, opposite over hypotenuse. So I can find angle A is the inverse sine of 9 over 23, which is 23.04 degrees. Okay? And then it's easy enough to find angle B just by taking 90 and subtracting 23.04, which gives us 66.96 degrees. And then finally, we got to find the angle, or sorry, we got to find side B. Okay. Now, again, there's a number of different ways we could approach this, but I'm just going to use the Pythagorean Theorem. I know that 23 squared is equal to 9 squared plus B squared. So I get B is equal to the square root of 23 minus 9 squared, or 23 squared minus 9 squared. Put that in my calculator and I get 21.17 for the length of side B. I guess I didn't label side B, but that's it right there. Alright, so there you go. There's the solutions for those. Now beyond that, these are just practice problems for you, and I will continue to go through the solutions. And again, you can pause the video, do them yourself, come back and look at the solutions. Alright, so here in this first practice problem, a surveyor must measure the distance between two banks of a straight river. She sights a tree at point T on the opposite bank of the river and drives a stake into the ground at a point P directly across from the tree. And then she walks 50 feet upstream and places a stake at point Q. And then she measures the angle PQT and finds that it's 58 degrees. And we're asked to find the width of the river. Okay? Alright, well, you can see the triangle there. Now, because T is directly opposite of P, right, we have a right angle here. And so you can see we have the opposite side is what we want to find, right? That's the width of the river, this distance D. And we know that she walked 50 feet upstream along the riverbank. So this distance from P to Q is 50 feet. Okay, so we have, and it's the adjacent side, right, to this 58 degrees that she measured. Okay, so we can just use tangent. So, let me say that again. Let's see, I'm going to write tangent of 58 degrees is equal to D over 50. Okay. And when I solve for D, I get D is equal to 50 times tangent of 58 degrees, which is 80.02 if you want to be more precise, meters. Okay. I don't know if it's necessary to be that precise. Depends on how precise she was in measuring. It may not be that important to measure down to the 2/100ths of a meter. Okay, but let's go on to the next one. Oops. All right, just put it there. All right, a search and rescue volunteer leaves a rendezvous point in the Arizona desert, walking 75 degrees northeast. She reaches a river that runs east-west and is located 1.3 miles directly north of the rendezvous point. How far east of the rendezvous point is the volunteer when she reaches the river? Okay. So, it's nice of them to draw a picture for us so we can see the triangle, right? We have a right angle over here, because that's the perpendicular distance to the river that we're given. And so what we want to find is how far east of the rendezvous point is the volunteer. So this is east-west here, so we want to find this distance here. All right. So you can see here also, we're given this 75-degree angle, but you can see our triangle is not there, right? So we could just If we know that this north-south line and this east-west line are 90 degrees from one another, then we could just say, well, this is 15 degrees, which tells us then that this is 75 degrees, this angle here. Okay. We could also use properties of parallel lines. If we're saying this east-west line is parallel to the river, then we have alternate interior angles. This 75-degree angle is an alternate interior angle to this other angle here, so that has to be 75 degrees. Okay. So, now we have the angles inside the triangle, and we can use sine, cosine, and tangent. I'm going to use this 75-degree angle, and so if the 75-degree angle is what I'm going to use, I have the opposite and I have the adjacent. I want to find the adjacent side. So the opposite side is 1.3, and I want to find x, the adjacent side. So x is equal to 1.3 over the tangent of, oops, I forgot 75 degrees. All right, let's fix that. All right, 75 degrees. 75 degrees. Okay, tangent 75 degrees. All right, put that in my calculator. I get 0.348 miles. Okay. And we got one more here. So let me scroll down a bit. All right, this one's a little trickier, but we can do it. All right, a bridge over a river was damaged in an earthquake, and you were called in to determine the length D of a steel beam needed to fix the gap. You cannot be on the bridge, but you are able to drop a line from point T, to the beginning of the bridge. Oh, all right. Point T is the beginning of the bridge. You're able to drop a line from T, the beginning of the bridge, and measure the distance of 50 feet to point P. From point P, you find the angles of elevation to the two ends of the gap. One of them is 42 degrees, the other one is 35 degrees. Okay? So you can see the two right triangles here. We got a right triangle here, we got a right triangle here. We know that this vertical distance is 50 feet. Okay? And we're given an angle, and what we want to know is, what is this gap? So really we have these two triangles that we need to work with. Okay? So let's start with this triangle PB up to the top here. I know they don't have this point labeled. But we can use the tangent. Let's say the tangent of 35 degrees is going to be opposite over adjacent. So we'd have 50 feet over the distance PB, okay, the distance from P to B. And that would give us that PB is equal to 50 over the tangent of 35, which is 71.41 feet. Okay. We could do a similar thing to calculate PA, right? So we can write that the tangent of 42 degrees is equal to 50, the opposite side, over PA. Okay. So that gives us that PA is equal to 50 over the tangent of 42 degrees, and that gives us 55.53 feet. Okay, and you can see the distance between these two lengths, PA and PB. The difference between them is D, right? So now we can find D by taking the difference of the two. PB minus PA. Okay, So 71, hang on, erase that. So we have 71.41 feet minus 55.53 feet gives us 15.88 feet. Okay, so our distance is 15.88 feet. All right,